Okay, let's get started. So I'm going to be recording this. This is why I'm wearing this. It's not somebody telling me what I have to say. I'm going to be recording this, so let's address this first. Every time we have a lecture, I'm going to upload the PDF of the slides and a video recording of the lecture so that if you're not comfortable coming in a crowded classroom or something like that, you can watch from home. If you miss a session, something, you can catch up this way, okay? So you're going to see that we have a lot of flexibility in this course, but I'm going to also warn you about, sometimes it's not because you have flexibility that you should use it. So we'll talk more about this. Today's session is just an introduction to the course. So pretty much what I want to talk with you about today is what are we going to do together? What's programming? Why do you have to take programming in an IT or cybersecurity curriculum? That's a question that came back recurrently, almost every semester since I've been teaching for USF, okay? So I think this is worth clarifying for at least those of you who are wondering why, you have to deal with programming. After that, we're going to go into more pragmatic stuff. We are going to look at the list of tasks that you must complete this week. So we have our first deadline. Our first deadline is Friday at 1 p.m. But be reassured, it's not going to be any testing on programming or stuff like that. It's just pretty much getting ready for the semester to start. Installing software, making sure that you have everything you need, and so on and so forth. So I'm going to cover that as well. And then the last thing we are going to discuss, depending on how the pace goes, we have like about 10, 15 minutes at the end to discuss that, is the overall course organization. So what I'm trying to achieve here is I'm trying to get every one of you, and I apologize already for that pillar there, that's kind of a little weird. I'm going to get all of you pretty much familiar with the kind of learning activities, the kind of dynamic that we are going to use this semester, okay? So exposing stuff up front like that works 50% of the time. So I'm going to do it. We're going to go over the organization of the course, and hopefully that's going to give you a good idea of what's going to happen, okay? And then as we go into each of the activity, I will remind you what are the expectation and so on the nature, all right? So let's move on, and let's start by establishing some ground rule for interaction, actually. So today's session is a little weird because today's session is going to be definitely old school lecturing, okay? I'm going to be talking a lot. I have a lot of information to give you. Generally, there are a few questions, like this morning there was one question, so that was on the low end, okay? Sometimes there are no questions at all during the whole session. It's okay for this kind of session, because if you think about it, I'm just trying to discuss with you, how the class is going to be organized. Once we start actually dealing with programming, okay, once the lecturer starts dealing with programming, this kind of, all lecture all the time is not the best way to approach learning programming. Don't worry, I'll come every session with a ton of slides. If you let me, I will go through the slide, I will lecture you the traditional way, if that's what you prefer. But what I really want you to invite doing is actually asking questions. So interrupting a lot of the lecture. Like I said, today's lecture is not really like the kind of content that yields itself to be interactive, but most of the time, yes, we are going to have opportunities for you to, instead of letting me cover something and then feel like, well, I half understood it, but I'm going to keep quiet and see where this is going. Instead of having that kind of approach, I want you to say, okay, I didn't understand what he just went over. I'm going to give him some feedback, actually, him being me, giving some feedback so that he knows that this is not going well, at least for me. And you are going to realize that when you have a question, generally, you're not the only one in the class that has that question, okay? So it pays for everybody if you are comfortable and open enough to actually interrupt the flow and ask whatever is bothering you, okay? So that means what? That means we have two ways to do that, and we're going to use both, hopefully. The first way is a traditional, hey, give me a little hand gesture, raise your hand, say something, ask anytime, any question during the lecture. The other way that I like to use, I use that online when I teach online a lot, because online we have those emoticons, right? So I can have everybody put a frowny face, in the chat window, and I know that whatever I'm talking about right now is not really passing to the student. Well, here we are face-to-face, so it has advantage, it has disadvantage. Disadvantage, we don't have emoticons, so you're going to realize that I'm scanning the room almost all the time, okay? Trying to read your body language as I explain things. I'm not that good. So that means that it's very easy for me to look at you and say, well, this guy, for example, is bored, or this person is bored here. And yet it's not that you're bored, it's just that you missed a step, like 10 minutes ago, and you have not been able to follow up since then. So don't rely just on me guessing your body language, because this is really the level at which it is, right? Guessing your body language, but let me know when things are getting a little over your head. Very easy to do. Just give me a little gesture. Okay, thumbs down will work. Anything that you can think of, like this, something like that. I don't know, but anything that will help me understand. Okay, over here, and over here, I have already 3 students that are feeling a little lost. Okay, if it's like one student is lost for one thing, then we can catch up with that at the end of the session, stuff like that. It's not a big deal. But most of the time, when I see 1 or 2 students that are lost about something, I will pause. I will try to assess whether this is, like global or not. And if it's global or even close to global, we can pause, rewind, and try to address the same topic slightly differently. And generally, like 2 attempts like that, that will bring 99% of everybody on board. You are going to realize that for this class, for this kind of content, programming, okay, it's a lot better, it's a lot easier for you to learn programming, to learn the content of the class, if you do not let things fly over your head, right? There are some classes where, for example, the instructor is talking about something, I didn't catch that. But I know that in 20 minutes, we're switching to another topic. So I'm going to be able to restart fresh for that new chapter, new topic, new section, whatever, okay? Programming is definitely not like that. So I want you to know what you signed up for, okay? Programming is not inherently more difficult or less difficult than anything you're going to learn in college. It's just different. The kind of different it is when I teach you something during week number 2, for example, I'm going to use it week number 3. And then the stuff I taught during the first 2 weeks, I'm going to use it for the next week. And it's kind of like having a snowball effect, right? So the kind of courses where everything is nicely compartmentalized, for example, discrete math, where you are going to go from learning about probability to learning about Boolean algebra and stuff like that, when it's nicely separated like that in almost independent topics, it's very easy to recover, okay? In a course like calculus or programming, where everything that we do keeps building on what we did, the week before that, it's really easy to lose your footing, okay? So I'm telling you that so that you know what kind of class you are dealing with, you know what kind of topic, and you adapt your learning strategies. You don't necessarily have to have the same learning strategies for every class that you are taking. There are some classes where you're going to walk in, you're going to study cram, the day before the exam, and you get an A because your mind is already aligned with that class. You know pretty much what's going on. You are going to have an easy time. There are other classes where the nature of the topic doesn't work well with that kind of strategy. You have to be able to detect that and adapt your own learning, to whatever the class is about. All right. So we'll keep talking about that kind of stuff. I'll try to give you warnings based on what I've seen work or not work for students in previous semesters. Other ground rules to abide for. This one is just to avoid having to hire a lawyer for my syllabus. My syllabus is already 20 pages long. This is awful. If I didn't have that rule, it would be 50 pages long. Every time you say you can do one thing, you would have to list everything you cannot do. So what we're going to adopt as prime directive in this class is everything that is not explicitly allowed, you have to ask about. Like you don't know if you can bring a calculator to your exam? Ask. We are going to use Piazza Forum this semester. Has anybody used Piazza Forum in our class before? So same thing this morning. Nobody touched Piazza Forums apparently. So you guys are going to discover that in this course. It's it's available in Canvas. So we're going to use a lot our Canvas course site, okay, for this class. And in the left panel in Canvas, there is a link to Piazza. Piazza is a sort of hybrid between a forum and a wiki. So somebody can post a question. You can even post question and remain anonymous. The instructor, just full disclaimer, I can see who posted the question, but your classmate will not see your name. So you can post question anonymously. Other students can add to your question, require more clarification on the answer that the TAs or myself are providing, and so on and so forth. So we are pretty much trying to build collectively an answer to not only the original question, but all of the sub-questions that other people might have been thinking about. So I really recommend you get involved with that. Like I said, you can post anonymously. So if you're a little shy or something like that, don't worry. This is not a big deal at all. But it has been very useful in the previous semesters to help students get answers very quickly. Because once you post your question, if I'm not online for whatever reason and a TA is online, they can answer. Okay. If the TAs are not online, but I'm online, I can answer, so on and so forth. Maybe another student is going to jump in and add something to your question that you didn't think about. So it's like, it's another of those snowball effect, but this time it's a good snowball effect. Okay. Yeah, the more people use that system, the better pretty much the learning experience, generally speaking. So we're going to use that. I recommend, very important, reach out to us meaning the TAs, which I'm going to let introduce themselves in a minute. The TAs and myself, reach out, early and often, okay? So often means there is no quota. You're not going to get charged even more on your tuition because you ask 50 questions, right? So everything that you think of, every question that you have, bring them up. We have a lot of office hours. You're going to see that in the next slides. Okay, we have a lot of office hours. We have Canvas message when it's something that's personal or about graded. We have Piazza when it's just a question about whatever we are learning at the moment in the class. Don't hold back. Okay, that kind of interaction, maybe it's not normal for some of you. It's not natural. Okay, you are used to classes where you come to the lecture, I do exactly what I'm doing right now. I speak a lot, right? And then you go home and you're done, etc. This class works a lot better for the student. It's a lot more enjoyable and it's easier for you to learn the more you interact, the more you ask questions. Okay? So do that early and often. Early meaning one of the heartbreaking situations that happens almost every semester is when I get that email or that private Canvas message 2 weeks before the final. And a student tells me I'm standing at a 43% in the class. I really need to pass this class. What can I do? And that's a heartbreaking part because there's nothing you can do. 2 weeks from the exam, in some courses, yes, in some courses you are going to be able, to cram and pass. With programming, it doesn't work like that. Programming is a skill. So it's not something that you have to memorize. I mean, you do have to memorize things, but it's not something that you can just memorize before to go pass the test and then succeed, right? You have an entire semester of work ahead of you to practice, to try to apply what we talk about in class by writing actual code, okay? And this is where most of your learning is going to come from. The lecture is a part of it, is going to get you started. The office hour are there to support you. This is a big part of it as well. But you actually taking the initiative to write code, etc., yes, that's what's going to pay off, right? So in this kind of courses, the 2 weeks, before the final last call for help doesn't work. If we had a way to make it work, I would make this class 2 weeks. We meet this week, next week, then we are all done. You gotta get an A, and we go get some time for relaxation. Okay? No, I don't have a way to teach programming that fast. Sorry. All right. What's next? That's an important one. I don't like to do favors to individual students because it's unfair. Okay? Like if a student tells me, I'm 1 point short from passing this class, can't you help me? Can't you do anything? No, not that I don't want to, but I don't want to do to all of the other students in the class, the affront of being unfair and giving 1 point here to somebody I like and then not giving any points to everybody else. So how do I address this kind of stuff? I always try my best to be fair to all of you with policies as opposed to individual help. Okay. For example, I have a 69.3. I really need to pass this class. Well, the way I address that is at the end of the semester, every grade is rounded up to the next integer. So 69.3 becomes 70. So nobody should find themselves in a situation that is that tight. Okay. Second thing that I do very often, almost every semester, is there are going to be some of our intermediary exams during the semester that are going to be more or less hard. Sometimes I try to gauge the difficulty of the exam so that it fits, what we're learning, etc. But sometimes I go overboard. When this kind of stuff happens, what I like to do is I set Canvas so that it drops the worst grade in one category. For example, we're going to have 9 quizzes, something like that. Well, I'm going to drop the worst grade. So that allows you, if you have a bad day, if you have anything happening, to have like pretty much a freebie one time during the semester. And if we do that for a different category of assignment, generally that's enough so that if something bad happens to you, but it's not, like terrible, it's not something that we can officially document and give you a retake or something like that. If it's just something annoying, well, then, your ISP went out. Okay, you will recover from that. Okay. I want the course to be challenging because I want you to learn stuff and not just get bored here. Okay. I want the course to be challenging, but I want it to be forgiving, meaning that part of learning is making mistakes. So you will make mistakes. I expect you to make mistakes. And guess what? I don't want you to fail the class because you made a few mistakes during the semester. So everything in this course is built with that philosophy, okay? Every little grade that you are going to get between now and the final exam is going to be one way to prepare you better for the final. The final itself is 40% of your grade. That's on purpose. That means that if everything goes well, you are going to take a bunch of quiz, a bunch of intermediary exam. You're going to make mistakes. You're going to get maybe like, so grades at the beginning. You are going to catch up, or you are going to do very well at the beginning, then have a few bad, intermediary exam or something like that. No matter what, by the time you reach the end, our goal is that every single mistake that you made, you could learn something from it. If you make mistakes and you jump to the next exam and you keep going like that, you're not going to learn anything. But if every time you lose points at an exam, you meet with your grader, you discuss it so that we can help you make sure you understand very well what caused you to lose those points, then it creates a system where you get better and better. It doesn't matter if you started the course knowing already everything, or if you started the course, without having ever written a line of code. By the way, this is the audience for which this course is targeted, okay? People that never coded before. It doesn't matter what your background is. We have a process that's going to make you make mistakes and learn from them until the final. And then, of course, the final is not really a learning experience. The final is an evaluation experience. So 40% of your grade, now it's time to know whether you are okay and ready to pass to the next class or not. But we are going to build to that progressively all over the semester. And again, depending on your background, you might not be used to interacting a lot with your instructor or a lot with your TAs. I really, really, really advise you to change that habit and use that class to get into the routine of asking questions all the time to your instructor, meeting with your TAs, going to online office hours. We are going to have online office hours this semester, so it should be super flexible. Okay, that's the one benefit of it, meaning that you can be at home working on an exercise. You get stuck on that exercise. Instead of spending the next hour, banging your head on the wall trying to make that exercise work when obviously something is not clicking, check out our schedule, figure out who is online available to help, jump online and tell them, I'm doing this practice exercise, I'm stuck. You jump online after 20 minutes of work on an exercise, we help you, get you unstuck in 5 minutes. You're going to get a lot more learning out of every single hour that you invest in this course. So I want you to work hard in between lecture and stuff like that, okay? This is definitely a class where you don't just attend the lecture and then forget about it until the next lecture and stuff like that. But at the same time, I don't want you to waste your time. So we have a way that we have refined over the years to make every hour you sink into the course as effective as we can for you. Please use that, all right? A little bit of logistics. So we are face-to-face on campus, but one remark about that, like I said, I'm recording. I'm really concerned about the audio quality, okay? So I have multiple solutions I'm going to try. I'm trying like a Bluetooth headset right now. You let me know if the audio quality is not good in the videos. Those of you will check it, okay? If that doesn't work, I'll try a lapel microphone. I mean, we'll test, through the semester and get something that works, okay? The only disadvantage with the lapel stuff is that I tend to move a lot, and this is wired. So, I mean, this is entertaining, but it's not really that great. We have 2 sections for this course. One in the morning, one in the afternoon. You can switch back and forth between them. Okay, I don't have any problem with that. You have a problem with your car in the morning, you come afternoon. You cannot attend afternoon, you come in the morning, okay? The only limitation that I will put on that is an obvious limitation of logistic. Like this room is pretty full, okay? The room this morning was even fuller than that. So we are going to see how things evolve, in the next few weeks. But the bottom line is that I don't want to have one session where I have only 3 students, and then like another session where we violate the fire marshal rule and we have too many people in the classroom, right? So we'll see. I've never had any problem like that because generally people use that as an exception. I have something to take care of this afternoon. I'm going to come to his morning class. But I'm just telling you, as long as it's reasonable, yes, maximum flexibility there too. Okay, and if we bump into problem, then we'll have to separate, by section. But hopefully it will come to that. The both of the section are going to be kept perfectly in sync. Okay, it almost never happens. I think it happens one time where one session went very fast with one group and it went very slow with the other group. Okay, when that happens, I try to stop. When we stop with the other group of students. But like I said, usually, it's roughly the same experience, morning, afternoon. You can swap around, no problem. What else? So I'm about to shut up for a few minutes here. What you have here is the same table that you have in the syllabus page on the Canvas course. Okay, so again, we're going to use that Canvas website for the course a lot. Okay, for Piazza, for all sort of stuff. We are lucky this semester. We have 4 TAs assigned to this class. I asked each of them to take half of their assigned hours. So those 2 TAs are assigned 10 hours a week. I asked them to set aside 5 hours each week to be available online, meaning that they will be on their computer grading, doing other stuff, right? But they will be in the online virtual room for this class, which is accessible, again, via Canvas. I'll show you how next session. But bottom line is that you just open Canvas, go to Blackboard Collaborate Ultra, and at those times, you will find somebody there. So total, there is like 20, 30, there's about 30 hours just of TA time, okay? And it's spread all over the week. It doesn't overlap with the lecture. Of course, that would be stupid, but the sessions don't even overlap with one another. So our goal is, even if you have a part-time job, even if you have a hard schedule for class this semester, we want to spread all over the place so that everybody should be able to reach us, okay? Again, to make you get more out of every hour you sink into this class, trying to practice by yourself. So don't hesitate to jump on, ask for help in any of the practice exercise, ask for detail about the grade that you last received and stuff like that. Now I'm going to let the TAs introduce themselves. I see 1 TA here. Yeah, okay, 2. All right, we have 4 TAs. One of them could not make it today. 2 of them are here. One of them could make it this morning, but he's going to probably introduce himself next session. But here you go.
So my name is Emily, and I am a teacher at CodingBat. So I will be holding office hours every Tuesday and Thursday, so feel free to come by and ask questions.
Hi, I am Satyan Sakhi. Currently, I am a PhD student. I'm a third year PhD student. And I will hold my episode on the Blackboard Ultra and Washington this year. So feel free to welcome me to my
We have a graduation, right? We have a sort of spectrum here. We have TAs who are undergraduate students. So they are probably the ones who remember the best, what you are going through right now. Then we have TA who are graduate students. So the 2 first TAs are graduate students. The 2 second TAs here are undergraduate students. So the graduate students are coming already a little bit towards the dark side, okay? And then you have the instructor. So if you are not comfortable working with me, contacting me outside of class, work with one of the TA. If you're not comfortable with one of the TA, try another TA, try me, okay? But we have a lot of options for you to find suitable support, okay? All right, one word of warning before we leave that slide. That's a trap, okay? 30 hours of TA, that should tell you something about the class, about the requirement, for you to learn hands-on by practicing in between session and always have like somebody online that can help you with, okay? So the amount of resources that we have for this class is indeed an indicator of what we expect you to do in terms of, practice, etc. So that's the thing with programming classes. I've heard it almost every semester when we talk with students. I ask them, what is the hardest part for you in this class, etc. They tell me the time. It takes me a lot of time. There are classes, again, they don't take a lot of time. This one is definitely not one of these, okay? I don't tell you all those things to scare you. I just want to make sure everybody has a realistic, set of expectation about what we're going to go through this semester. And more importantly, I want you to be warned so that you can already prepare yourself, adapt your learning strategies and stuff like that. Okay? All right. So what's the deal with this COP2512? So I've been teaching a lot, like for the last past years, I've been teaching 2512, 2513, back and forth, okay? These are two of the four state-mandated prerequisites. So the four state-mandated prerequisites are discrete math, intro to DP, programming fundamentals, and then object-oriented programming, okay? These are the four classes you need to complete and gain a sufficient grade in so that you may then transition into your major fully, okay? Cybersecurity, information technology, whatever it may be, all right? So we are here, we are like taking care of those prerequisites. So the obvious job of the prerequisite is to make sure that when you pass those classes with us, you have like the baggage to be successful in the program, okay? We could do a very light-hearted version of this class, where we have a lot of fun and we don't get a lot of learning done, but then you would pay for it in the program. Actually, you would pay for it here. These are the two prerequisites. This is, by the way, the diagram for information technology, but the cybersecurity one is very similar. These are the two programming classes that are state-mandated prerequisite. And then here you can imagine a line here. When you pass this gate course, this is literally a gate course. You have to pass through it to be able to go to the rest of the course, right? This is your entrance. This is your gate to your major. When you take this programming class here, Advanced Program Design for IT, passing this, I think with a B or plus B minimum, is going to be required for you to be able to continue with the program. So my goal is to, yes, to give you the kind of baggage, that you can carry over through the entire program, but it's also to more specifically make sure that you learn programming well enough that when you come here, you're not going to go like, oh, wow, that was easy, and now suddenly this is really hard, okay? That class select students, okay? It's programming again, it goes back to the fundamentals, the kind of stuff we're going to talk about this semester, but it does so, even in proper English, it does so with a programming language that is a lot less friendly. We're going to use Java. Java sometimes is boring, Java is sometimes very ceremonious, verbose, but the good thing about Java is that it is friendly to the programmer. It tries to help the programmer. So if you try to do something stupid, generally Java stops compilation and tells you, this is maybe not the best way to do it, right? Give you some sort of feedback, some warning. The programming language that you're going to learn here, the C programming language, has a totally different philosophy. The C programming language was written by, it's overusing the word, but by hackers for hackers. Not hackers in a cybersecurity sense. Hackers is a sense of somebody writing another operating system, for example. The people who wrote that language are the people that wrote the Unix operating system. So they didn't want the language to tell them they were not good programmer because they were already excellent programmer. They wanted a language that would diligently follow instruction. If you say jump, the language jumps over the cliff. Okay, so that means what? That means that when you write code, if you write bad code in Java, generally you don't even get to execute it. The compiler is going to catch you before and tell you this is wrong. If you write code in C, the compiler will say, sure thing, you know what you're doing, and then you're going to get bugs. Okay, bugs that can be very difficult to track. So the way that we are trying to prepare you for that is in 2512, 2513, we use Java. So think of it like you have like a Nerf gun, okay? And then in COP2515, you get the full bazooka without safety. But by then, we hope that you know enough about programming that you're going to be careful. You're going to have that self-discipline, right? To be really careful about what you tell the computer to do. Because you know that with C, it will just jump through the hoops and do whatever you want it to do, right? So that's kind of like the philosophy there. So we have those four classes here. Data structure is another one of them. These are your four main programming classes. So I mentioned that because in previous semesters, I had students that told me, I really don't like programming. Can I just grind through this class, and be done with it? So I want you to have a heads up. You are going to have at least four very programming heavy classes in this curriculum. And then it depends. Like, for example, human computer interface. Yeah, I can see how somebody would teach it more based on concepts, okay, instead of actually coding. Web system, no. I don't know how you can possibly teach people about web system without having them write at least some basic web application, front end, back end, right? So your mileage might vary, but those 4 classes, yes, definitely programming heavy, okay? So I went already over this, what is our goal, prepare you, etc., blah, blah, blah. So now let's talk a little bit about what is programming itself. So here's the first definition of programming, for what it's worth. Programming is like riding a bike. It's its own thing. That's the thing with programming. It's its own specific, different skill. Like I said at the beginning, it's not necessarily harder or easier than other stuff, but it's different. So for some of you, it's going to come naturally because that's already your way of thinking. For the others, which should be the majority in this class, okay, this is going to look like a totally alien way of going about solving problems. That's the fun of it, is that you are not just going to learn fact in this class. When you learn programming, you're not just going to learn technical jargon or keywords or concept. You are going to actually learn about a new way to think your way through problems. And that's a very interesting part of programming, okay? So even if you have a little bit this feeling at the beginning that your bike is on fire, just don't pay attention to it, okay? The first few weeks are going to cause you to have to get used to a lot of new stuff. And then progressively, you're going to fall into that routine. You're going to start acquiring the thinking pattern that is specific to programming. And then it's going to get easier and easier, okay? But don't let yourself be discouraged by the first initial impact, which is, oh my God, this is totally different from what I've done before. Let's try to make a little bit more serious definition of programming. When you are programming, you are solving problem, okay? You are solving a certain class of problem, algorithmic problems. Algorithmic problems are problems that can be solved with an algorithm. That was a nice circular definition right there. What is an algorithm? An algorithm is a detailed step-by-step list of instructions, okay? So any problem where I can tell someone, a human, an animal, a machine, I can give them very explicit, detailed, step-by-step instruction on what to do to help them solve the problem. That's an algorithmic problem. That's not all the problems, okay? Most of the problems actually are not that nice. But algorithmic problem, yes, they can be solved by writing a list of step-by-step instruction. So the hard part of programming is right there. Some people think programming, I'm going to look at code examples and I'm going to memorize them. And then when the exam comes, I just, regurgitate and I'm going to be okay. No, programming is not about that. Programming is, here's a problem that you've never seen before. Here's a new customer, a new client. This client is from accounting. This client is from biology. They present you with a problem that you've never seen before. You are going to break down that problem so that you can solve it step by step. So in this class, we are going to use relatively easy problem, okay? In terms of, I'm not going to ask you to go get a degree in accounting just so that you can understand the next exercise, right? We try to always play with a domain, with a theme that is almost already known by everyone, so that the only difficulty you have is really on how to identify the step to solve the problem. Once you have identified the steps to solve the problem, then it's a matter of translation. I know in my head what I want to do in my program, okay? But it's still a little vague. Now I'm going to write it down in Java or Python or C or C# or whatever language you are using at the time, right? I'm going to translate the step-by-step instruction in my head into actual code. That step is actually a part of the programming process. It's not the hardest. That's the hard one, the problem solving. This one you can brute force through it. You can memorize the syntax. It's like learning a new language, okay? If I want to teach you some basic conversational German, for example, I completely suck at German, so that's why I use that example. But if I wanted to do that, for example, then you could actually survive through that kind of class by relying 80% on memorization. And that's what's going to happen for that too. The Java language is very easy to learn the syntax. You memorize it. But here's the caveat. If you don't memorize the syntax, if you think, oh, this is easy, I'll figure it out, I'll let it grow on me, etc., then you're going to bump into a problem. Because if you don't know how to express your ideas, then you're not going anywhere. You might have a very good idea in your head about how to solve a problem, But if you cannot write 2 lines of Java without having 55, syntax errors in them, that's not going to work out very well, okay? It's going to be painful. So make sure that you understand the syntax, memorize it, learn it, and then everything else is going to be a little easier. We don't just write code because we want to write code. Generally, we have a client that tells us, I want a program that does blah. And that statement, I want you to write for me a program that does blah, is called requirements. It can be more or less detailed, more or less ambiguous. Real life requirements are ambiguous, okay? You are going to miss the days at school where you were taking a class and the instructor and TA, even though they are not always successful, we were trying our best to make the requirement clear for you. Because in the real world, the last thing that a client is worrying is really making the requirement clear. They want to dump on you everything that they have in their mind about what they want their product to be like, and it's up to you to sort this out, organize it, and then solve the underlying problem, okay? But for now, we're going to try to make those requirements clear as we can for you, get started, progressively. And what you want to do is you want to write a code that satisfies the requirement. So I read the requirement, write a program that computes, I don't know, factorial, the factorial function, whatever. I write my code. I really think my code works. Otherwise, I would have written it differently. So how do I actually know that I'm done? We're going to use test. So what is a suite of tests? It's just, you can even do it on paper. You can write down on paper, when my program receives this and this input from the user, so here's a list of the input, this is what I expect the result to be. So you have a column for everything that you feed your program, or multiple columns. You have one column or multiple for what your program is expected to do. Once you agree with your client that those tests actually capture the requirements, okay, they capture all the essence of requirement, then you make a bunch of tests like that, you show them to your client say, yep, this is how I want the program to behave. And every time you write your code, you run it through all those tests and you check, is the output that I get matching the one that I expected? If it does, test passed. Move on to the next one. If it doesn't, either the test was a bad idea, the test was badly designed, or most likely you have a bug. Okay, your program features an unexpected behavior on one of the tests. So we are going to use tests in this class, not because I want you to become quality assurance engineers. These are the people that test a lot of software, okay? But I just want to give you something pragmatic, like a goal in mind, something to go for while you write code, so that you don't end up falling into that trap that I've seen some students fall into, where they write code, but they kind of try to follow the requirement, but it's all confusing and vague in their mind. So they write code, and then at some point they're done and they say, I have no clue what grade I'm going to get for that. Because I really tried to match the requirement, but how do I make sure? Test, okay? So we are just going to learn enough, like a little bit, a tiny bit about testing, just to give you this confidence, just to give you this process where you don't just write code. You have a goal in mind, and that will help you go through all of this. After all of this, okay, it doesn't matter. Everything I've said so far doesn't matter. There are a part of you that are going to say, yeah, I'm taking a programming class. I like programming already because I did it in high school, whatever. There are some of you that are thinking like, why am I here? Why do I have to listen to this stuff about programming? So I'm going to try to not necessarily reassure those students, but address their concern, okay? Why do you have 4 programming classes in IT or in cybersecurity? So one of the ways that I found to address this is by going to one of our professional organizations, ACM, and more specifically the special interest group in IT education. And they came up with that little, it's not really a diagram, it's a picture, whatever, that was supposed to help explain to people what information technology was, okay, or is. So we're talking about 10 years ago when IT was still very poorly defined. They used that diagram to try to educate the masses. So IT has things like, for example, information assurance and security. So those of you who want to go in cybersecurity, you're going to get intimately familiar with this, okay? It relies on different technical areas, 5 of them: programming, networking, human-computer interaction, database, and web system. So we could argue day in, day out, about whether there's more to IT or there's less to IT, but I'm just going with what one of our professional organizations identified, publicly as a good representation of IT. And what I want to use this diagram to show to you is that, and this is based on very, very scientific data, exact data, right? No, it's not at all. It's just like a little, a lot, definitely a lot, medium. Those bars represent the impact of programming in each of those pillars of IT. And you can see that if you do networking, I had only one student come back to me and say, I'm working as a network administrator, and I had to use programming to automate the update of a bunch of Cisco routers, okay? This is the only student, to be honest, that I heard back from that went into networking and that told me I'm using programming, and I'm glad about it, right? But over aspects of IT, like especially web system, there is no learning web development or doing any form of web development without actually programming. So is programming pretty ubiquitous and spread all over? Yes, you are not going to be able to avoid it. But here's the good news, especially if you really don't like programming, okay? Here's the good news. You don't have to become a full-fledged developer. That's not my goal with this class. That's not even the goal with the entire IT or cybersecurity program. We don't want to turn you into full-time developers. We want to give you just enough exposure to programming that you're not going to run away from it. You're not going to be that system administrator that got hired like 30 years ago, that hates programming, doesn't know anything about programming, and has been able to have a successful career until now. But every time in a meeting, somebody say, hey, we could automate those tasks by writing a 10-line script. That system administrator steps back and say, no, we don't need no scripts, right? No, you don't want to be in that kind of situation. We don't want you to be in that kind of situation, because if anything, the trends that we have observed in IT and cybersecurity just tell us that programming becomes a lot more essential. Plus, actually, you are already the generation who started doing programming, if not in middle school, maybe in high school. How many of you took like middle school, high school courses in programming? Okay, so this is going to keep growing, okay? So maybe in 10 years or 5 years, or I don't know when, I'm going to say programming and everybody's going to say, yeah, I've done that for like already 5 years. Then we'll change the content of the course, okay? But right now the course is still for first-time programmer. But what I'm trying to show here is that the trend is more and more people are going to be aware of programming. So even if it's not your thing, bear with me, work with me. I don't have any problem with a student coming to me and saying, I hate this course. That's okay. But then we can work together, try to find a way so that you survive this course. And to a certain extent, maybe I can get you to enjoy a little bit programming, okay? So be honest, talk to me outside of class, and we'll try to work something out, okay? This slide, I'm going to pass relatively quick on it. It's just examples of programming in IT. So the only one I'm going to use right now is web development. 20, 30 years ago, you could be a web designer if you knew how to do HTML, okay? HTML, and maybe you know how to cut and paste some 5 lines of JavaScript that you found on a website, and suddenly you have these little bars, at the bottom of your web page that does funny things. That and animated GIF, they were awesome. Just kidding. That was the 90s, okay? That doesn't work. That doesn't fly anymore. Like a front-end web developer or even a web designer nowadays is sufficiently familiar with CSS and JavaScript that they can actually write code in JavaScript. JavaScript is a great language. I love it. It's a little weird, but I love weird. So, but JavaScript, the issue is that it's not a beginner-friendly programming language. So to be able to use JavaScript, you need to know those object-oriented programming concepts we're going to learn in the next class, for example. To be able to just use the code that other people wrote, okay? Not even like write a lot of stuff by yourself, but just to be able to use one of those JavaScript frameworks that some of you might have heard of. So we are really at a situation here where it's unavoidable, okay? Programming is definitely unavoidable. We are going to try together to get you through this and make sure that you have solid skill enough, not only for the next class, for your graduation, but potentially for the next 5-10 years of your career, so that you're not taken into a weird situation where suddenly your degree is worthless. All right, so we are going to focus on concepts a lot. That's really my primary goal. I want you guys to know about the main concept of programming. But knowing about concept is not enough. Like, for example, I can listen. I always use quantum physics because I am I am beyond help for quantum physics. So if I listen to a quantum physics documentary, maybe I will feel like I understood some stuff. Maybe I can even like sound smart in a conversation by using some of the terminology that I heard about. But that doesn't make me a quantum physicist, right? So the idea is here for programming that, yes, our first level is I want you to understand concepts, but then I want you to be able to apply those concepts as you write code. If you find yourself in a situation where you think, I understand everything in this class, the concepts are easy, but when it comes time to write down the code, I'm stuck. So give yourself a little bit of leeway there. Maybe you don't understand all the concept as well as you think. Because if you did, then the transition to application would be easier. Would be still a step up, but would be easier, okay? Java, I don't want to make you professional Java developer. I don't want to prepare you for a Java certification. These things are useful. I'm a big proponent in students being prepared with an education, their degree, certifications, and experience. These are the three components for an ideal candidate to hire for a job, right? So I'm not trying to downplay the role of certification. I'm just telling you this is not the role of this course to prepare you to a certification in Java. We just use Java the same way that we could use any programming language. We don't care. We just need one programming language that allows us to apply the concept. Yeah.
Like, I will say once more, like, what about like Python? Like, I just don't understand like
So
one over the other.
let's address that. Okay, Python is a great language. Okay, next year I'll be probably using Python as well for the introduction to programming, just to test it out. So there are two aspects. Okay, is Python a useful language for IT and cybersecurity? Yes, 1,000 times yes. You guys are going to be introduced to Python, if not before, at least when you take data structure. Okay, so it's totally our plan that by the time you graduate, you have had some exposure to Python. Now, the only thing that I'm concerned about, and I'm going to start evaluating it next year, right? The only thing that I'm concerned about is when I teach with Java, Java is verbose, is annoying sometimes, but it doesn't let you get away with much, okay? In Python, even though the language is simple to learn, you may be able to do some neat stuff in Python, and actually your code is total crap. Okay, like what I mean by total crap is you have some misunderstanding about how Python works, but you still manage to write something that somehow kind of like two wrongs make a right, end up doing the job that you wanted to do. I know because I've been there. Okay, when I first started with Python, I wrote awful Python. I still write like semi-decent Python only, but I wrote really awful Python. But the language was so nice and so accommodating that I could get my job done. Even for after 6 months rereading my code, I was like, I had no idea variables work that way. I just assumed they work like in Java. So Python is very good for the professional IT cybersecurity person. Okay, I'm going to see how good it is as a first language, because a lot of people say it's a great first language, but a lot of people also teach programming by making it very entertaining, very fun, very easy. And then when you reach COP2512, you're like, well, crap, this is a little bit more complicated than what I was led to believe, right? So you have to strike this balance. I definitely want to use Python. It's a great language, but I don't want to use Python in a way that I'm going to get all of my students to write tons of code, get some fancy stuff happening on the screen, and then they develop bad programming habits, and by the time they take COP3515, all of this is going to crumble down. Okay, but that's a fair, legitimate question, and it's definitely timely. You had Python before? Yeah. A lot of people use it because, like I said, even if you don't understand the language very well, it has a way to allow you to write code that somehow works. Okay, but then the difference is, do you want your code to work? Yeah, I do. But do you want to also understand what's happening? And this is where you can maybe with Python, you can get tricked a little bit. All right. So this is the most verbose part of the introduction, right? Now we're going to look at concrete stuff. You have 4 tasks to complete this week by the deadline of Friday, 1 p.m. The first one, read the syllabus. Yes, I spoke a lot, I know, almost an hour already, but I didn't try to cover everything we have in the syllabus. The syllabus is our contract, okay? So take the time, one time at the beginning of the semester, to read through it just to make sure nothing is bothering you, okay? If something is bothering you, if you don't feel like you can work in those conditions with me this semester, first contact me, because there's always a chance that it's an old cut and paste from an old syllabus, blah, blah, blah. I'll clarify, I'll fix, okay? But it's really the ground rules for us to grade you, to evaluate you, to work together. So it's worth taking a look at, okay? I'm not saying hire a lawyer to look through it for you, but I'm saying pay attention, okay? This is like, we always refer back to the syllabus when there are problems. Task number 2, we are going to work with the Java programming language. So you need to install the Java programming language on your laptop. Here's the link. You go there, you're going to be able to download it from there. If you go to java.com, it's going to lead you to a similar link, okay? It's going to probably try to auto-detect what kind of operating system you are working with. Bottom line, go there, take the latest version of Java. Whatever is the latest version, download it. I don't care what number it is. I lost track a few semesters ago because we use only very basic features in this class, right? So I don't care of the latest feature in Java, but download the latest version. The only thing you have to be careful about is there are 2 versions of Java. When you install Java on a machine, there are 2 things you can install. One is called the JRE, Java Runtime Environment. It's like the absolute minimum Java installation you can have on a machine, and it allows you only to run applications, okay? That's not what you want. What you want is the other one, the JDK, Java Development Kit, Developer Kit, whatever. That's the one, as the name implies, that is for people who are going to write Java application on their machine. So you want to go to that website, download the latest version of the JDK for your machine. If you are using if you're using a PC, that's going to be Windows installer, MSI or something like that. If you're using a Mac, you have to know whether your Mac is using the new M1 chipset. In that case, this is going to be an ARM installer. This is a kind of processor that you have with M1. And if you are using a Mac that is using an Intel chipset, then it's going to be x64 or x86, okay? So anyway, if you have problem with that, tell you what, this is why we have office hours as well, okay? So don't hesitate to come and see me and the TAs during office hour with technical problem. Our goal is we want you to be completely set up by the end of the week, so that next week when we start actually writing code, we don't have a bunch of students that are like, my system is not still working, I have problems, because that's going to set you back, from the get-go. If you have problems, come and see us, okay? But most of the time, one of the problems you're going to encounter is if you have already several versions of Java, sometimes that can lead to confusion. So the second link is to help you clean up your laptop with removing the old version of Java. Yeah, you had a question? So I'm going to upload, don't worry about that. I'm going to upload the PDF of the slides at the end of every lecture, okay? So generally I do it after the morning session. This morning I didn't have time to do that. So I'm going to do it before my office hours tonight. I have office hours from 7 to 8:30 p.m., something like that. So if you have working at whatever, you can still come to late office hours. And I will upload the PDF and the videos for the course. So good question. You don't have to worry about jolting down those links or stuff like that. The second piece of software that we need to install is, so Java is a language that we are going to work with. We're going to write our code in Java. The second thing we need to install, we could do without, honestly. We could just use a text editor and good old command line. But what we're going to use instead is we're going to use pretty much a glorified text editor that is customized to edit code. So the technical term for that is an integrated development environment. It's integrated because you can edit your code and you can click a button and it's going to be compiled and executed and tested, etc. Everything is right there at your fingertips, okay? The one we're going to use in this class is called JGrasp. Go here, click download, same process, select Mac, Windows, download your stuff, install it, okay? And after you're done installing, there is a little video, a short video on YouTube here that's going to allow you to test that everything is working. So that video is going to make you write a little program, like 2 lines or something like that, in JGrasp, and make you click the button to compile it, to make sure it's proper Java, and that your Java language is properly installed, and then run it to make sure, again, everything works. If you can do everything in this video, you're set. you are all set for the rest of the semester as far as software that you need to install on your laptop. Okay? Not every well, so don't forget that if you have any problem at any point, okay, office hours. One question that comes up very often at some point in the semester is, I don't like JGrasp. I already did programming before. I'm used to one of those professional grade IDE. Can I use that instead in the course? Yes. Other possible scenario that happens, I started this class knowing nothing about Java. I use JGrasp, but now I see my classmates are using, let's pick one, Visual Studio Code. This thing is awesome. It does automatic code completion, stuff like that. Can I use that? Yes, asterisk, asterisk. So what is the caveat? The caveat is what I want to avoid, and I've seen happen a few semesters, is a student takes a professional grade IDE. They are not familiar with it. They don't really understand how the IDE is organizing the files on the hard drive and stuff like that. And what actually happened in the past during an exam is I would give an exam, tell you download this file, you download it on your desktop, then you open it with one of those IDE. Visual Studio Code is pretty good at that, but Eclipse is the one that students have problem with. Eclipse makes a copy of that file, copies it into a separate folder, opens an entire project for it. You work on your exam for 2 hours, and then at the end, you upload the file, you go to your desktop, you upload the file that you have there. That was the file you downloaded. If you don't know that Eclipse made a copy of your file in another folder, if you don't know how it organizes things, then what just happened to you is you turned in pretty much the almost empty file that I gave you to start with and that I wanted you to modify. Okay? This happened a few times to the point where I don't want to have students lose any points because of this kind of stuff anymore, right? So the best way to avoid that is to use JGrasp. If you want to venture into the world of professional IDEs, because you feel you are ready, my advice would be Visual Studio Code, because it's lightweight. It doesn't actually do a lot of that project management. And then as you start using IntelliJ or NetBeans or Eclipse, then you are going to deal with tools that are, again, meant for professional developers and that are going to take charge of your code. They are going to organize your code on this certain way. They are going to require you to have package, stuff like that. If you already know your stuff, I don't want to stand in your way. Feel free to use those tools. But if you are just beginning, follow my advice, okay? Use JGrasp, at least for a few weeks, get comfortable, and then we'll revisit whether you're ready, to go to a professional grade IDE. All right. Task number 3, go to CodingBat.com. That's a website. This is a website that has a bunch of exercise for both Java and Python, so we're going to use the Java side for now. Go to CodingBat, register for a free account. Please use your official USF email address to register your account. So something at usf.edu. Do not use something at mail.usf.edu. That's kind of a vestigial thing. I don't know why it hasn't gone away yet, but it's still around there. It's not going to work out, okay? So your official email address ends in at usf.edu. Use that one to register your account. If you do that, we are going to be able to assign you exercise on that website. You're going to go to that website. You're going to complete the exercise. So this is what the interface is really simple. It tells you, write a piece of code that does this. Here's a few examples of what happened when you call your code, the result that I expect. I'm going to cover all this, don't worry, right? And here's a window where you write your code, okay? And you click the go button, and what happens is that it compiles, it runs the code in your browser, and it tells you, okay, this is how good your code is. So it's going to show you a table where it's going to tell you pretty much, when I called your code with this input, it returned this output, and this is exactly what I was expecting. I messed it up. I expect that, and I got that. This is exactly what I was expecting. It matches, test, passed. So this is going to give you feedback very quick to tell you how much of the stuff that is required here your code is able to do so far. So that's why we use that tool. It has built-in tests like that that help students get to the point where they can write their own tests. But before you write your own test, I want you to have some software that's going to help you get good habits. So you go to that website, you register, you click on that link, and you type this. If you can read it on the slide, you're going to get full test success. If you type this, this is like a dumbed down version of the solution that doesn't do even half of the job, you're going to see green, red, 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 green, green, red, red, red. Some of the tests pass, some of the tests fail, okay? At this point for this week, I just want to make sure that everybody is able to click that go button and have some green and red stuff show up. That's it. We are checking that your hardware, your laptop is ready for you to start working next week. So that's task 3. And to finish task 3, actually, I want you to do one more thing. There's going to be a link in Canvas. I forgot the name of the assignment, but it's something like CodingBat link. Okay, you click on it. It's kind of like an assignment, but it's not graded. It's just going to be a text box where I want you to cut and paste the URL. That URL is going to be our way to access with an automated script your records on codingbat.com so we can give you automatically grades. I'll re-explain all of this when we get to it, okay? But right now, I want you to get set up. So to get set up, open your account. When you are logged in CodingBat, you're going to see your email address somewhere at the top right. There's going to be a done link. You click on this, it shows what we call the done report or the done page. This is pretty much a list of all the exercises you've completed. That's it. You take that URL, you go to Canvas, you click that link for the first module that says CodingBat link, you paste that URL. No need to type anything, no need to put any text, just put the URL. We are going to collect all those URLs this week, next week, okay? And then we'll use that to automatically give you points whenever you complete exercise. So it's not going to be like right away. Like if you complete an exercise, you don't get the point right away. But what happens is that every week I run a script and the script goes back to your records and gives you credit for everything that you completed successfully, okay? All right? Okay, and that's the main part of it. And then the cherry on the cake, task number 4. So install Java, install JGrass, get your account on CodingBat. And then task number 4 is first week quiz. So deadline 1 p.m. Friday. You need to complete the quiz by 1 p.m. Friday. You need to score 100% of the points on that quiz by 1 p.m. Friday. The quiz has nothing to do with programming. The quiz is just a glorified checklist. Do you have your textbook? Did you install Java? Did you install JGrass? You see where this is going, right? It's just a few things that I want to make sure we're on the same page on, you and I, okay? That quiz is very important for. It's trivial in the sense that it's just a checklist, but it's really important for administrative reasons that add just enough dramatic, to what I was trying to emphasize. Perfect, thank you. So it's important for administrative reason, all right? The deal is we have to take first day attendance. The way that we take first day attendance in this class is like I do it in my online classes. I'm going to give you that quiz, you click on it, you take it, you score 100% on it. Friday at 1 p.m. automatically, everybody who got full points on the quiz get marked as present. Automatically, anybody who didn't take the quiz or responded, no, I don't want Java, no, I don't want the JGrass, no, I don't want, well, pretty much you don't want to be in this class then, because that's what we're going to do. So if you answer no everywhere, you get 0 point or whatever, you're not going to be marked present. So everybody who's marked absent, now you guys fall into the administrative limbo of USF, meaning that you don't necessarily get dropped from the Canvas site, because that would make too much sense, but you get dropped for the course. So both things can be out of sync sometimes. You get dropped for the course, and then we have to petition to get you back in, or you have to try to re-register, see if there are free slots available. I think we have plenty of open seats, so you should be able to, but you know what? Just let's avoid it, okay? There are things that are going to be hard in this course that we cannot avoid. This is a kind of burden on you, on me, on anybody that we can avoid. Just make sure you take that quiz by 1 p.m. Friday, and you are golden, okay? All right. What else? We are going to use Onolog. So another thing that this quiz is going to do is going to show you how online proctoring works, because you are going to have a lot of exams that are going to be purely online. We have an online proctoring system called Onolog. That first quiz is going to force you to install the plugin in Google Chrome, and it's going to show you how it works. When you start an exam with Onolog, a quiz, an exam, or whatever, you have to show your student ID card to the webcam. You have to go through a certain process. This is going to allow you to make sure you have all of this working before next week, okay? And if that doesn't work, generally, that means the page tells you what is the password. There will never be a password to anything in this class, okay? So that means that if your browser tells you what is the password for this exam, what is the password for the first week quiz, that means there's a problem with the plugin. 99.9999999% of the time, that's what happened. Just go into Google Chrome, go into your plugins setting, make sure that honor lock is there, that it's enabled, because sometimes some privacy add-ons are going to see honor lock and try to shoot it dead, because honor lock is nothing about really privacy respect. Okay, so they are going to disable honor lock. Just make sure you re-enable it before to take a quiz or an exam. Okay. All right. General rule. Here's a secret recipe in information technology. If something doesn't work, try the 3 R's. Retry, reboot, reinstall. And if that doesn't do it, then come to office hours. Our TA and myself will be there to try to fix, whatever problem you bump into. Our goal is, if you guys are going to have any technical problem, let's have them all this week. This week we spend it making sure everybody's laptop is working 100%. And after that, we don't have to worry about anything for the rest of the semester. Last thing I want to discuss quickly, because we have 10 minutes and this is easy stuff anyway. How is the course going to be organized? Well, we're going to have lectures. That's not really a news. I mean, if you're sitting here, you've suffered through one already. The only thing I want to emphasize here, ask question anytime during lecture. Don't hesitate to interrupt. Attendance is not taken. I don't do that. You guys are adults. Attendance is not optional. See the confusion here, the paradox? So that means that, yes, you are expected to attend those lectures. If you cannot attend the lecture in the morning, come the afternoon. If you know you are not going to be able to come the afternoon, come the morning. If you cannot make it today, you are sick or you want to get tested for COVID because you're not sure if you have it, yes, please go get tested. You will have a video. And as you catch up watching the video, office hours, you will have the TAs and I that are standing by just to answer your question. It's not as good as if you were asking the question right when I was saying something, but with a little bit of luck, you're watching the video while there's somebody standing by, during office hours. So really, it's going to be just the time for you to log in and connect and ask your question. So it should not be too bad, okay? So lecture is a part of it. Reading assignment. For the first 5 weeks, we're not going to have a lot of reading assignment from the textbook because I don't rely too much on the textbook yet. And then after week 5 or 6, depending on how fast we go, we're going to start relying module after module, topic after topic on the textbook. So at that point, I will give you formal reading assignments, okay? These are not optional. These supplement the lecture. So there are some details that are in the reading, not the lecture. There are other things that are in the lecture, not the reading, okay? So keep that in mind, you have to do both. How do I make sure that you listen to a 1 hour and 15-minute lecture or you read 30 pages of textbook and you retain a lot from it? How do I make sure of that? Anybody, if we read or sit through a lecture, generally I would say 60 to 80% of the content is retained, okay? I'm talking about usual performance, not trying very hard for a lecture that is going to be hard or something like that. So about 40% of everything that's said, or 20% if you're lucky, fly over your head. You are thinking about your T-Mobile bill being due or something like that. Yes, that's what we do. We're humans, okay? So this is where we have a fail-proof system. Not only you're going to listen to the lecture, read the reading assignment, but we have a bank of quiz questions that come from the textbook publisher. We are going to have them available as PQ. Every time you click on the PQ, you get 5 random questions on the current module. You click again, 5 random questions. Use those as we go through the lecture to make sure you don't miss anything important. So you read through the textbook, you get 60% of the material, fire up the PQ, open it up a few times, it will tell you what you missed, okay? And then you refer back to the textbook, you come to office hour. Bottom line is, no matter how you do it, you just were told, hey, you missed something, and now we're going to fix it together or yourself by rereading, okay? But we are going to make sure that you don't miss anything important. And then, so for those things, you can work with other people. You can work with classmates, you can have study groups, you can ask as much help as you need from the TA. And then we are going to have graded quiz. Graded quiz, same thing, same format, but it's take only once, and you get a grade out of it, and it's proctored using honor lock, okay? So the general idea of the course is lectures prepare you for the reading. So lecture as a concept, some of the detail, then you take another take at it with more details through the reading assignment. The PQ help you make sure you don't miss anything from the reading of the lecture. And when you are ready, at the end of each module, you take the graded quiz and you get an evaluation of how well you actually retain that material. So you have constant feedback. Feedback that doesn't count for your grade, just to help you learn. Feedback that counts for your grade to motivate you, okay? And then I'm going to skip fast on the side because the details are there for you to read, but the general idea is the same way we have practice quiz, graded quiz, we're going to have practice exercise and graded exercise. The graded exercise will be on CodingBat. The practice exercise will be just exercise that I assigned from the textbook. The practice ones are not graded. You can work on them together. The graded exercise, yeah, it's personal work only. But the logic is the same. If the quiz are there to prepare you to make sure that you understand the concepts, and the techniques, and the jargon, and the syntax, right? The practice exercise, graded exercise are going to make sure you can apply those things by writing actually code. So these are your two pathways to acquire those two halves of the programming skill, understanding the concept, being able to write code. And then every about 2 weeks, okay, maybe sometime more, maybe sometime less, okay? This is something that I kind of tune depending on how I see the class going during the semester. We are going to have what is called intermediary exam. They are take-home exam. They last anything between 1 hour to 2 hours. Or beginning of the semester, they are going to be closer to 1 hour. Towards the end of the semester, closer to 2 hours, because they are here to prepare you for the final. So this is an exam where you are going to log into Canvas. I'm going to ask you write a piece of code that does this requirements. Okay, you write the code in Java for like 1 hour, 2 hours. You upload what you have at the end of the 1 hour, 2 hours, and then we grade it. This is where the TA are going to spend most of the time. They are going to grade continuously those IE. Every time you have an IE, we try to get it graded within a week of the deadline. So you get feedback from the TA. Every time you get feedback from the TA, every time you lose one single point in an IE, meet with your TA during their office hours. Discuss what happened, what went wrong. Sometimes it's just simple, I forgot something. That's okay. Now you're never going to forget it again because you lost some points. But sometimes it's bigger problem, right? You have like some sort of misconception and you are looking at it completely wrong. That's what's going to help you and us detect those kind of misconception. So it doesn't matter how many mistakes you make in the IEs, as long as you follow up and learn from your mistakes. If you do that, I guarantee you that each of the IE is going to progressively get you ready and readier for the final exam. They're going to start looking more and more like the final exam will look. So we are going to complete this diagram by having the IE prepare you for the final exam. Final exam is going to have the same format as the IE. It's going to be the same level of difficulty that the last 1 or 2 IEs that we have in the class, okay? This is your scaffold. If you follow that scaffold, you should be okay, all right? If the scaffold doesn't work at all for you because you don't learn that way, I need to hear from you, okay? This always happens, like a student doesn't fit really with that scaffold. Doesn't mean that they are not going to be successful in the class. Just means we need to talk one-on-one, evaluate, how you learn and how we can modify those things so that they don't impede your progress. And that's it. So as usual, all of this stuff is going to be as PDF on the Canvas module section. And then I'm going to generate the video sometime this evening and upload it as well, so that if anybody needs to catch up, every session you will have a video. Thank you so much for listening through all of that, blah, blah. And see you, Wednesday? Yes, the final exam will be definitely on campus in person, okay? Everything else can be flexible, but the final exam I definitely asked, and the answer was no. So we definitely need to make it in person.